It was good. Got a quick question for today. We're still on electrochemistry, kind of similar to the question we did yesterday. I'm just trying to pull up the data sheet real quick, but yeah, bro, nothing too complicated. My bad. I'm just stalling until I load the thing up. Okay, so a constant current of 0.2 amps, or as an amplitude, amps, was passed in a solution of nickel 2 sulfate for 30 minutes. How much nickel was deposited? So we need to find out the mass of nickel that was deposited. How do we do that? Well, we got to use the equation, and I need to get my data sheet, my formula sheet. My bad. I'm super unprepared for this, low key. Okay, so here, what are we going to use? We're going to use Q equals IT equals NF. Similar to yesterday, except yesterday we were looking for, amplitude, but we have that. So we're kind of like just doing something similar but different at the same time. So we got intensity, we got time, we don't know the moles, and we do know Faraday's constant, so we're not going to be using this one here. So here, how do we find the number of moles of electrons? Well, we're going to first want to write down the half reaction that is occurring. So we got nickel 2 plus will go into nickel solid plus 2. Wait, no, electron should be on the other side. Two electrons. Now, what do we need to do? 2 electrons. Okay, so we know that the number of the moles of electrons is 2. So that's all we need to do for that portion. So what are we even trying to find now? Oh, we have to relate it in a different... Okay, wait, so let's just solve for n here. So we know that 2 electrons is in the reaction. Now we just gotta solve for Ne to see how many electrons are actually transferred, how many moles of electrons are transferred during this 30 minutes, and then we'll relate that number of moles of electrons to this reaction. So I was incorrect in doing that, but we could just leave it there. So IT over F. Amps is also coulombs per second. So we need to make 30 minutes into 60 seconds. 30 minutes into seconds, so 30 multiplied by 60 divided by Faraday's constant, which is, I hate school, bro. I'm so excited to get the semester over with, but this summer I'll just be studying even more, bro. Wall. But why is... Bro, I hate when it's like view one page, but it's not continuous scroll, and it always goes to that by default. Okay, 96485 coulombs per mole. Okay, 0.2 multiplied by 1800 divided by 96485. 0.003738 actually. No, 37. Let me just make sure that we're on pace. Yes, sir. Okay, so now looking at this, wait, let me just make sure the reaction's right as well. Yeah, okay. So now we have 0.0037 moles of electrons, and we need to relate that to here. So here, to this half reaction. So for every 2 moles of electron, we get 1 mole of nickel solid. So we just gotta cancel out moles of electron. What's this? Oh, that's I. For 2 moles divided by 2. 0.0019 moles of nickel solid. Now we could find the mass of nickel deposited by using the molar mass of nickel. Molar mass of nickel here is 58.6934. Bro, I have to MC for an event tomorrow, bro. I just went to rehearsal and I spent so much time there, bro. I just want to die, bro. Zero 0.109 grams. I believe that's the answer. Word. That's the answer. Boom. We're done. That was actually pretty light, actually. Not gonna lie. But yeah, I'll see you tomorrow. Goodbye.